Let me just say, if this is your first time watching, I say welcome. If you're a repeat offender, I say welcome back. I have been wanting to look at this meter for a long time. My friend Fred, who's gone on to God, used to sit there and talk about all the different possibilities that would be available to us as radio operators, not just the amateur community, not just the CB community, but all of us as brethren as radio operators. We would talk about the different flexible capabilities of this meter specifically, way back when it was in R&D development a long time ago. And it's a shame my friend Fred didn't get to live long enough to get to watch me do this video. He would have been happy. I've got to tell you, I was a little on the fence with this, but once this thing got here and I had the opportunity to work with it, all I'm going to say is overwhelmingly surprised and satisfied. I'm really excited to walk you guys through this, from unboxing to explaining how to operate, all the way up to let's see how much power we can really put through it. And believe me when I tell you, I'm pulling out all the stops. The family at Telepost have been incredibly supportive for me. This is one I've purchased. I am not a shill for this company in any way, shape, or form. This is just something that I feel very strongly about. And this is once again one of these products that I've come across that I felt I should stand behind and say, hey, this is something everybody should take a look at. This is more than just a watt meter. That is for sure. On that note, thanks to Telepost, and let's get on with the show. I cannot overexpress how excited I am to get to play with one of these meters. I wanted to do this for a while, but just haven't had the opportunity. It's finally here. This time is finally here. So for me to play with the meter, we've got to unbox it, right? Well, you only get to unbox it once. This is the LP500. Okay. We ordered this one with all the couplers that it could possibly come with. It's got the latest and greatest firmware in it. This is the latest and greatest, as of the recording of this video, that can come from Telepost. Larry over there has been very supportive of this, and he was kind enough to sell this to me. So I thought, well, before I start playing with it, I want to actually do an unboxing. Unboxing videos for this channel, very rare. It's not how I normally roll, but I got a lot of faith in this person, and I got a lot of faith in this company, so I figured we'd do it the full money. Now, how nice is that? Right out the hop, an actual printed paper manual. I got to tell you guys, most of the companies these days won't even provide you this. Serious, you go to MFJ or one of those other corporations and buy something from them, they're going to tell you to go to their webpage and download a PDF. So a full color paper manual. I love it. Now, he strongly suggests that I read the manual 2 or 3 times, spend at least a couple days fiddly farting around with the meter, and then call him. Then he's going to send me more updated firmware for this thing, and then I can start all over again. But don't be discouraged. It's not that complicated. It's not. So this is coupler number 1, and this is the LPC, looks like 002. And it's the LPC 501, I think. I don't know. I can't read it through the little foam. I don't know what that is either. USB to Firewire. Let's make sure I'm using the right terminology here. This is the USB 4P-A/MA USB 4PB-MA. Going back to when I used to play with computers a lot, that's a Firewire cable, USB-C or whatever it is. A network cable. This is a Cat 6A shielded RG45 black 7-footer. We've got 3 of those. Standard power lead, which I believe is the same size. Let me make sure, verify this real quick. Let me walk over to my LP100A, take a quick look at it. Exact same plug size and cable size as the power wire for the LP100A. Beautiful. And the unit. That's it. That is everything that you will receive with the LP500 in the box. Now I get to start the most fun part of the whole thing, is teaching myself how to use this, which I don't think that's going to be that complicated, but away we go. Okay, so we got our unboxed now. What we're going to do is we're going to do a 360 on it. So this is our front, obviously, front, bottom, front. There's our sides, and then our back. Now, right here on the back of the unit, we're going to have a ground plug. Now this is important. We're going to come back to this in just a second. You have your PTT, A and B, your USB 2, test tone, our coupler hookups, and our power. The power works with 11 through 16 volts, as it clearly says on the back of the unit here. But according to the little legend, it's showing us that the center conductor is hot and the outer jacket is ground. So, with a little bit of brain power, we're going to go and we're going to take a look at what our center conductor is in our color code. I'm pointing this out because the particular power cable that I've got, either it's going to come and it's going to be marked and it's going to say plus on it, or it's going to have a ridge on it. Okay? So let's figure out what our center conductor is. Now what we just performed on that little test is I wanted to see is if the writing on this cable was positive or ground, or if the ridge side was ground. And on this particular cable, with this particular unit, the writing, smooth slick connector is positive, and the ridged rough side that doesn't have any writing on it whatsoever is our ground lead. Very important that we need to determine that before we plug in the unit. Before we plug in the unit. Okay, so now let's take a quick look at the back of this unit. Now that we've figured out our power wire orientation, because we don't want to damage anything. The cost of the unit is so high that I don't want there to be any confusion. And the reason I did it with the multimeter is because I want you, the operator, to figure out what the power plug orientation is for your own safety. Now on the web page, and if you call and talk with Larry, he'll tell you exactly what it is, but I want you to be able to figure it out as the operator for your own safety and the equipment safety. Okay, so now that we got the power wire figured out, let's take a quick look at the back of this unit. The ground plug is going to come in really handy. I have several friends that have this, like about 100 at this point, it seems like, on the last one to the show. They've been having problems with the meter having fluctuating readings, and what we've determined the issue was is they didn't have everything properly bonded. Not grounded, bonded together. So you bond the unit to your transmitter, however it be, radio amplifier, or your ground, your station ground. It also could be suggested that you might need to bond your coupler. We'll get more into that later on down the road. These are your inputs, 1 through 4. The way I like to think is small, bigger, bigger, and biggest. Or it could be small, bigger, bigger, and biggest. Doesn't matter, that's up to your preference. This is how you're going to interface with the unit with the USB connection for firmware updates and so on. It's going to be through this port. Your PTTs, a lot of amateur guys use push to talk. That means a foot pedal or a secondary device or a keying unit that comes off the radio or a signal from the radio that puts the amplifier and all the other pieces of equipment into the transmit mode instead of it being auto sense. This allows you to loop into that particular function in your station. A lot of CB guys, they work in a completely auto key environment where all they do is they mash the microphone and everything is auto sense. The amateur community and some of the CB community, they figured out that you're just going to destroy your relays by using auto sense most of the time. So they've converted over to the PTTs. There's some pros and cons to that. We're not going to get into that today. That's not the point. All right, let's move on. Let's hook up and, well, let's first show off the couplers. Then we're going to hook up some couplers and then we'll power the unit on. So straight out the hop, let's take a talk about the couplers. This is the LP 3000 watt 1.8 through 54 megahertz coupler. Then over here we have the next up in size, which is the LPC 502, which is the 1.8 through 54 megahertz 5000 watt coupler. Exactly the same. And then the big guy. This is the LPC 505. These are made, he doesn't manufacture these unless you actually request them. This is the 1.8 through 30 megahertz 15 kW peak. These are all peak couplers, by the way, you guys. Peak envelope power. But we're going to thoroughly test these. Each one of these couplers to their maximum. On the inside of here is just a piece of 393, RG393 coax that goes between the two connectors. And the magic shmoo that takes place on the inside is a video for another day. But now that we've thoroughly documented what came out of the box, what each piece looks like, how to orientate our power plug, what do you say we get a network cable out, we turn the unit on, and let's see what happens. Okay, so before we plug anything into the unit, no power, no nothing, first step we're going to do is we're going to hook up a coupler. Coupler hooked up. And we're going to come around to the bag of this thing and we're going to plug into channel 1. Just like that. Now we're going to hook up our power lead. Just like so. And let's turn on the unit. Let's play. I'm dreading this part of the video because it's so monumentally boring to me, and I know it's going to be boring to you guys, but we've got to go over this stuff. So let's start from the very beginning. You're going to have your power button that you're going to depress. It's going to take about 3 to 4 seconds for the thing to boot. Of course, it's a little mini computer. Okay, so we've got our adjustment knob, and then our touch knobs, F1 through F6, and then as we progress through menus, it is touchscreen in some limited form. The adjustment knob over here is also present. This is an optic driven knob. This isn't a resistor of any kind. This is a fiber optic adjustment knob. It's going to be implemented later on with some of the screen options that we're going to go to here in a few minutes. First off, I want to say it's highlighted in the instruction manual on page 1. The pan adapter, this thing, the Spectrum display monitors transmit signal only. Okay, so the spectrum shot that you get is only on the transmit side. I want to be very clear about that as we go forward. you cannot use it or the demodulation jack in the back to drive a pan adapter. That was pointed out to me very clearly for multiple different reasons. As of the time of shooting this video, I don't even think this is the current firmware that's in here. I think that they have upgraded since then, but I am running version 2.52. So if you end up getting your LPE 500, it's going to come loaded with the newer firmware on it. It might differ slightly from this video. Okay? So let's go cover and talk about the jack on the back of the unit, the demodulation jack. It's also an audio source jack. Okay? It's technically set up for line level input rigs, which might require like the W2IHY box, which is a nice cool piece of kit that I'm working with him over there right now to go ahead and do a video like this on a showcasing of his equipment as well, because I'm impressed with it. It's neat. It's very straightforward plug and play equipment. It has been suggested that most rigs you're going to need to use a 10K resistor on the output jack on the back, and that jack on the back is primarily for the use of audio, for you to inject into your radio, for different measuring purposes in use with this meter. Okay, it's strongly suggested, and I agree with this, that you buy at least 2 couplers for this unit. It's not necessary, but you want to think about having at least 2 couplers. A coupler that sits between your radio and your amplifier and your antenna. Okay? By having the 2 couplers in play, it allows you to make sure that the input signal going into your amplifier does not have any input reflect. It also allows you to guard for high SWR at your antenna. Having the 2 couplers in play also comes in handy as we're going to progress forward and through the explanation of things. A thing called Trapezoidal Tuning, which I have been struggling for 2 days to figure out how I can kind of put my spin on it to make it more not technical based and make it more human English. Okay. It's also strongly suggested that you go from your radio, your PTT out on your radio, to this. If you're an amateur operator, you'll know exactly what I'm talking about. You're going to go from here, loop this into play, and then go from here to your amplifier with your PTT, or otherwise known in the CB world, a foot pedal. Let this drive your amplifier. Let's start there. Okay, so your mode button, obviously it changes modes. And the thing I want to point out to you is if at any point you get too far lost in the menu, just turn the unit off and it'll take you back to your home page. Okay? So if you get too lost down the rabbit hole, just hit the power button. When the thing reboots, it's going to take you back to the beginning stage. Your channel button here, this is what allows you to switch between couplers, F2. Your ring button auto. Ring would also be for your range button. Okay? Then you got to have your alarm cancel alarm on, then you're going to do average, and then your setup window. All right? Okay, so like I was saying, your first impression of the mode button is going to take us over here to just your very basic oscilloscope audio form analyzer. Okay? This is going to be what channel you want it to be applied to. This is your division, otherwise known as your sweep rate, and this is going to be your mode, CW, PSK, and linear 1, linear user 2, user 3, and sideband, CW. So for all intents and purposes, we're going to leave this on sideband fast. Hit mode button again, and this takes us into our spectral mode. Okay? Now, spectral mode is kind of neat. I compared it against my spectrum analyzer. It takes you out to 2,000 kcs wide, and there is a lot of different measuring forms with this that we're not going to go into specifics in this video. Once again, it's in the manual. Let's go talk about the magician behind the screen here. Let's use the setup button. This is how you're going to adjust pretty much everything that runs in the background. Your alarm threshold points, your screen brightness, your peak hold, the channel title, all that kind of stuff. This is where you're going to adjust your call sign, or what shows up over here in the bottom left hand corner of the screen. It'll also show up when you boot. Okay, the very first thing that's going to be highlighted is the coupler channel. As you scroll through the channels, you're going to see that a lot of these little numbers here are going to change. We need to make sure that you have the right coupler on the right channel. Odds are that if you order this thing from Telepost, when you get it from Telepost, whatever coupler that you've ordered, if you've only ordered one coupler, it's going to be assigned for channel 1, and that coupler info is already going to be entered in for you. If you've bought multiple couplers, as you progress up in power, I have noticed channel 2 is set for the 3000 watt coupler, and channel 3 is set for the 15,000 watt coupler that I have sitting here attached to it now. You want to make sure that whatever coupler you apply per channel, that your sub settings are set appropriately. Okay, let's scroll on down. And in future versions, you guys, this knob is going to come into play on the screen. He hasn't had a chance to write it into the software yet. Like I said, this knob does have a detent to it and a scroll function. Okay, let's scroll on down. Power alarm. This sets the power alarm trigger point for the selected channel. It can either be set from 2 to 2.5 kW in 10 watt steps for the coupler LPC 501, and then the other couplers it's going to adjust on up, which is covered in the manual. For instance, the 5 kW, it's going to be in increments of 20. The 502 increments of 40, and then the 503, it's also going to be set for the maximum peak values. The 505 is set in an increment of 3, as in 300 increments. So let's go and look at the next step down. That's going to be SWR alarm. This sets when the alarm trigger is triggered point and for the selected channel. So it can either be set for 1.5 and all the way up to 5. So if your SWR exceeds, let me explain this to you in English terms. If the unit sees an SWR higher than 1.5, it's going to trigger the alarm. Let's adjust this up. It allows us to see, it'll go, hey, you got a problem if your SWR goes over 2, 2.5, 3, 3.5, 4, 4.5, 5, and it's just going to stop. It doesn't cycle back to the beginning. And remember, guys, at any time you get too far lost down the rabbit hole, at any time, just simply hit the power button and it'll take you right back to the mode screen when the unit reboots. So if you get too lost down the rabbit hole, just turn the unit off, turn it back on, and it'll come back. Okay. Let's slide on down here to power mode. It selects power mode type either in NTE, FR, IE, delivered power, or forward power, or forward reflect. All right, that's just how it's going to display it to you in normal terms. AL SWR threshold. The minimum power required to activate the alarm and SWR display. Use higher values to prevent fast or false triggering from the other transmissions in multiple contest environments. 1 to 1, 3, 10, 30, and 10, and 100. Let me translate that, what I just said, to English. Right now, for the SWR bridge to make an accurate estimate on what's happening, this is our threshold. So it's going to take a minimum of 3 watts worth of input power for it to accurately have an SWR reading. Now, depending on where you have this range set, is going to change your SWR overall ratio, which is important to understand, especially in different applications with the meter. Leave it in auto. That's what I'm going to tell you. Okay, SWR determines the graph style for the SWR display when not transmitting. Do you want it to sit at 1, 0.0, or its last hold value? So if we adjust this, last, 0, or 1. Now let me show you, physically show you what they mean by that. We're talking about this window right here. Do we want it to show 1.0, which is perfect? That's a perfect SWR. That means it's a 1-to-1 ratio. Everything going out, nothing coming back. My way of thinking, the way I work, because I am so used to doing everything with a set of bird meters and thinking in terms of reflect. For me personally, I would adjust this. Oh, there we go. I want to adjust this to read that. So when we come back out here to the main window, it means 0. It's just what we're talking about, is this right here. Now, the last couple settings probably were a little bit confusing for you, listening to my explanation. I had to wait until we got to this setting for us to tie it all together. The last couple settings determine what is displayed here. This window. This window. What our reflect numbers are, our return loss is, and then total overall displayed value. To me, I would leave it in this window for myself. Most other people, I would strongly suggest that you're going to want to leave it here in 1. It's the way most people think. Okay? I wanted to take a minute and pause on this and really point this out. But me personally, I like it like this. Okay, scrolling on. This is our screen brightness. If we adjust this up or adjust this down, please note 50%. See how bright it is at 50%? 100%. When the unit is in operation and you're using it and you're actually looking at it and you're thinking about it and you're doing your thing, this is the overall brightness. Peak hold time. How long do we want it to hold on to the maximum peak value that gets displayed? When we fire down, this thing lights up. You're going to see this happen. I think I covered this in some video segments that I've already shot. When you fire down, let's say you put 100 watts out there. Bloop. Well, you might have modulated just a hair past that. It's going to hold on to this if you are in peak hold mode. Average, tune, peak hold mode. The tune mode is the most sensitive setting that you're going to be able to put this thing to for watt measurement. The coupler takes a sample 40,000 times a second. 40,000 times each second. If we were displayed 40,000 points of data here per second, this display would just be bzzz, jumping all over the place, and it would drive you batty looking at it. It's handy to have this screen for myself. This is the way I like to think about it. It's handy to have this screen available for you when you're doing your initial setup tune, but for you to really get things dialed in, me personally, I go to peak hold, then I'm going to go over here to setup, and I'm going to scroll down to setup, and I would adjust this to 0.5. So every half a second, it's going to update the screen and tell you what the value is at that half-second interval. I don't know about you. I am, well, let's face it, everybody knows it. I'm not a rocket scientist. This, to me, seems to be the smoothest setting to look at in my brain, with my brain's way of thinking being orientated from a bird environment, to be honest with you. This is just enough refresh rate for that when you do an input into your amplifier or your transmitter in some way, that there's enough delay to where you're not getting lost in the refresh rate from the sampler, but to actually show you what your input has done with your carrier level. Now, we can adjust this up. So if you put 100 watts into it, or let's say you go hello, and you modulate, let's say it does 175 watts, it's gonna hold on to that 175 watts even though you're not talking, or you're not generating any power, or it's fallen back to its base carrier level. It's gonna hold on to that 175 displayed for 5 seconds, and then it's gonna refresh the screen. This is a preference thing, you guys. Preference thing. And let me physically demonstrate what we just talked about in this last little segment. See, we're sitting at 0. I want 0 because it shows me that there's nothing going on. This is a preference setting. We just went over this. We're also in tune. Hello, 1, 2, 1, 2, 1, 2. Let me turn my mic gain up here, and I'll show you what I mean when it comes to this thing making a measurement. Say, oh, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, hello. In tune mode, see how fast this thing is refreshing? Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Now if I take it to peak hold, hello, 1, 2, 1, 2, 1, 2. Now how quickly it gets rid of this data is this setting here. So what I just demonstrated to you guys, and let's tie it all together, is our peak hold time, where if I adjust this up, let's go back to the main menu. I'm off the key already. And it's going to take 5 seconds for this data to get wiped off the screen. And then we have our average setting. Hello, 1, 2. It's not going to show us our peak value. It's going to show us our average value of the peak number. But the peak hold is what I wanted to come back and really emphasize. Now, the other thing I wanted to talk about, let's see, scroll. Let's turn this back down. It runs smoother in my opinion this way. It's a call. It's your guys' judgment call. Let me scroll back through the menu, and I wanted to come back here and pause on this. As you start to go up in power, you're going to want to adjust this up. The reason for that is if you have this set low and you have, let's say, like a 16 pill. I had a friend of mine that was using one of these. He was using a 16 pill or 24 pill, and every once in a while he'd key down and bleep, the alarm would go off, beep, and he'd unkey thinking he had a problem. What that comes from is in the circuit, you've got multiple relays opening and closing, especially with guys that use auto key amplifiers. This probably would have never presented itself, this little glitch, in a manual operated station. When you have an auto key system in your setup, you fire down, the relay doesn't move until it sees some RF come to it, and then for a nanosecond, as that relay is making its motion, it's going from this connector down to this contactor, it draws an arc, zzz, and then zap, draws another arc as it starts to operate. Auto key. It's great up until about 1,000 watts. After that, you really need to think about either going to a foot pedal, which is a manual form of operation, or what they call PTT. In the amateur world, it's PTT. When you hit push to talk, it's going to send a send signal to the amplifier. It says key up. The amp's going to key up, and there's like 100,000 or 100 millisecond worth of delay built into the system that nobody ever takes account of, and it's so the relays can latch, go from receive into the transmit mode, and make sure all those circuits are involved. And this is inside the amplifier is what we're talking about now. For a nanosecond, remember, our meters sample 40,000 times a second, the samplers do. So it's going to detect that high SWR as it's breaking the two contacts, and will give you an erroneous high SWR. This has now presented itself with my guys in 2 different setups that I'm aware of. To help overcome that, this is in a better way of thinking about it, a buffer. So it's not going to trip if it only sees 30 or 40 watts. It's not going to trip immediately and give you a false alarm. But as soon as you go into operation over here, if this SWR gets too high, it will trip. Just something that I wanted to cover and demonstrate. Hello, audio 1, 2. By manipulating the peak hold, it takes us away from this little spasmastic tune setting. Hello, 1, 2, 1, 2, hello, hello, hello. Spasmastic. Hello. Let me expand on that definition one more time, and then we're going to move on. If you have more than one coupler in line, let's say you have a coupler between your radio and your driver amplifier, and then a coupler between your driver amplifier and your big box, and then another coupler at your big box and antenna. If you don't have this setting adjusted appropriately for the coupler that's between your radio and your driver, as the auto key circuit is working, it can trip the SWR between the radio and the driver. It's going to see that high SWR, and that high SWR is there when the relay is moving through its arc motions, just the arc of its movement. As it breaks contact from one and goes to the other, there is actually technically a high SWR that's present there. And because the coupler reads so fast, it's going to show you on that coupler that there's a high SWR, which can lead you to believe that you have a problem with either your driver or between your driver. And usually your driver, that level is usually right around about 1,000 watts, at least for my guys in the CB world. That driver's around 1,000 watts. So the coupler that sits between the driver and, let's say, whatever the big box is, if you're running an auto key circuit, when you first fire down, your base carrier, your dead carrier is relatively low, but it's still got to break that contact, which is going to draw an arc on your relay until it grabs up the next relay contact point. Technically, you're going to have a couple hundred watts that are transmitting into nothing. So the meter's doing its job. It's showing you, hey, on this coupler, when you first key up, there's a high SWR. It's a false reading. Because when the relay finishes its movement and latches up and energizes the 16 pill, let's say, or 24 pill, or 32 pill, or however you want to go about thinking about it, the SWR drops off to 0 again. Once again, peak hold comes into play, and this buffer level here is what determines what's going to trip it. So if you have, let's say, the 1500 watt coupler between the radio and the driver, you're going to set this at about probably 15 or 20. Okay? And if you go on up the food chain a little bit, where you go to your driver and a big box, you're going to want to set this up as high as you can get it. It's not going to hurt the unit, and it's not going to hurt the driver in any way. This is an adjustment that allows us to be able to tweak the meter to say, you know what, because the SWR is, for that half nano millisecond, is a little bit high, as long as we don't exceed this threshold, don't trip. Chill out, everything's cool. Now on your antenna side of things, that's where you want to change and dial this in to be a little bit more on the money. I wanted to make sure to point that out, especially for my guys. And bear with me, guys, we're halfway through this. We get on the other side of it, that's when it gets fun. So here we go. Okay, let's scroll on down. This is something that's been added to the firmware since the instruction manual was written, okay? This is your channels 1 through 3 title. You can give each channel its own specific name. So if you wanted to set this up for a commercial setting, or even in your own station, you could utilize this too. You could label channel 1 that says transmitter. or radio. Then channel number 2 is going to be amplifier antenna or antenna. For my particular station, it would be radio driver, so it would be radio. So it's showing you what the radio is putting out and forward and what the reflected power into my driver is. Then we're going to have another one that's going to say driver. It's going to show me what my forward power from the driver is, and then reflect. And then a final amplification, otherwise known as big box, Vader. It's going to allow you to see the input to that. So it gives you multiple different stages of measurement. And it gives you the flexibility to name each channel. I thought that was pretty slick. So we're going to scroll up here to the right-hand corner. This is your ability to adjust your call sign, or otherwise what shows up here is going to show up here and also on the boot window. So WKRP in Cincinnati. If you want to put WKRP up there, that's how you get to adjust it. Okay? Okie dokie. Let's go back over here again. Screensaver time. Now, me personally, I like to set this at minimum intervals, because when I'm done talking, I am done talking, and I want this unit to shut off on its own. I don't want to have to reach up and power it off. I've had my LPV 100A on now for 5 years, and I rely on these two settings to take care of that business. Screensaver takes you to half brightness. So how long do you want it to count down on a timer until this screen goes to half brightness? And then sleep time is how long do you want it to count down on a timer for it to shut completely off. And what I mean by off is the screen goes blank. The meter's still in the background doing its full chooch money. It's doing its job in the background. The instant it sees any incoming RF from either your transmitter or your amplifier, or sees anything move through the coupler, within 40 thousandths of 1 second, this thing's going to wake up and give you information and say, oh, let's go. This is a cool little function right here. The screensaver reset is what that stands for. Okay. Do you want it to set up and reset the screen, otherwise turn the screen back on after it goes into sleep mode with either RF, or do you want to have to reach up here and hit F1 to wake the unit up? The thing can stay in standby forever. I like to have mine auto sensed. So when it sees any RF go through it, that's when it wakes up. Some guys might not like that. They might want to walk in, turn all their equipment on, sit down in front of their radio, get their microphone pulled down. Swr for life, by the way, not Heil. Pull down your Swr microphone. I say that in T's. I say that in T's. Pull down your boom mic, or pick up the microphone unit, get themselves all situated, and then start turning everything on. And one of the things they might want to do is just to be able to reach up and hit mode button, and that's what wakes the unit up, by depressing F1. Me, on the other hand, this is the last thing I think about when I'm firing up my station. And as soon as I bump the microphone, bloop, my little key switch that I have, this unit would automatically come on. So it's going to be an RF sense in that situation. Otherwise, it's going to be mode. You can set it so it does both. I can walk by and I can hit mode, the unit will wake up, or I can just put a little bit of RF through it and it'll wake up the same. Almost done, you guys. I know this is mind-numbingly boring. It's okay. Somebody out there, though, is going to find this useful, and that's the reason that we're all sitting here enduring this. Alarm volume, 100%. Obviously, how loud your alarm is going to be. Your alarm pitch. Do you want it to go beep, you have a problem, or beep, you want it to have a problem? This just changes the tone. Okay? This is something new they've added to the meter, and this is peak response value. Do you want it to respond in 100 uniseconds, 50 uniseconds? And it has something to do with how you want the unit to respond to multiple fast peak values, like high speed CW, that kind of thing. And then our beep volume. Do you want it to be high? And what they mean by beep volume is every time I depress the trigger, I don't know if it's getting translated to the microphone or not. Do I want it to be high, medium, low? I mean, personally, I don't care if a button makes noise. I don't care if it's got a little vibration, offset motor weight that makes the screen have what they call catalytic feedback or whatever. I just want the value to change. So that, and I'm half deaf, so we'll leave it on high. Okay, we made it through. We made it through. As I scroll this knob around, you'll see that we're changing our average to fast, medium, and slow. There's a lot of people that said the average read mode on the LP100A was not good for anything. I disagree. I think the average read mode worked just fine on the LP100A, but this allows you to adjust the average display refresh rate. Let's move on. I'm just going to tell you that unboxing segment took a full day to shoot and took 3.5 hours to edit. Guys, I don't think you recognize how much time and energy goes into a lot of these different video projects for you all to consume. This is not a small task. One, getting the piece of equipment, talking to the manufacturer, getting all the people on board, and making sure everybody's notes line up and mesh for us to be able to do a video like this. And I really, really, truly, please, I pray that you guys click the subscribe button, because I'm always doing projects like this, and I'm just going to stop doing them if people don't want to get on board and they don't think it's helpful. But so far, every one of these projects that I've done like this, people have really, really responded positively to it. So please understand, this whole video is going to represent probably 4 days, maybe 5 days worth of work, physical man hours per day. And that every detail that I'm going to cover in here is something that somebody else had to teach me. Okay, and that represents time that Larry has taken away from his business to be able to sit down and discuss with me on the topics that I didn't understand. In this particular meter, there was a few. So, listen, we do this because we love it. Believe me, it's not because YouTube is paying us a ton of money. Now, I want to say another thing up front and make it very clear. I'm not the Telepost whisperer. Okay, I'm not the LP100 know-all. That's the guy that built this thing. Okay, Telepost doesn't have a giant platform to be able to promote their product on. I got a little bit of a platform, so that's the reason I'm out here doing the video. So if you have questions about your LP or have questions about this period that I don't cover in this video, please contact Larry. I'll put his number here or up here, or digitally I'll do it somehow later in post. Believe me, guys, call him. Don't call me. I have just the tip of the iceberg as far as knowledge is concerned. He's unbelievably smart, and he will sit and talk with you to answer all of your questions thoroughly and do whatever it takes to make the situation right or help you understand how to operate your meter better. Believe me when I say that. It is a fact. When you go and start doing projects like this, like, I'm sure you all remember where is it? I have it sitting over here. This fine turd of technological junkness. You guys remember this junk box? This plastic piece of junk. This is an SDR switch that we proved without a shadow of a doubt will actually cause your SDR to become desensitized and ruin your receiver. Okay, it's plastic. I went through and I filled this full of copper and shielded coax, and I did all the stuff that should have been done. The people that put their trust in these big corporations, they end up pumping out a pile of garbage, and then so one of us come along and kind of object to it. We get thrown underneath the bus because, well, what do you know? You don't own a multi-billion-dollar corporation. Yeah, you're right. I don't, and I never want to. Look, it's the fine details as you get older that you start to notice. And please, guys, do not go inside this meter and start poking around. That's the reason we're going to do it on video, so you don't have to. But what I'm talking about is this is not punched out of some cheap, thin, 62 thousandths aluminum cabinet. This is substantial metal. It's been painted and coated, baked in an oven, and then somebody went along and on every single one of these cabinets they had to clean off the connections to make sure that we had a decent shield on our measuring device. To one, keep noise inside the box, and two, to keep noise from the outside universe out of the box as well. It's the small details. Let's switch up to this camera up here above. So this is the inside of the LP 500. Now, another thing I want to point out to you guys is Larry asked me to make a point behind this, is that we want to keep our voltage that's feeding the unit that comes in through this jack right here closer to the 14 volt range. Okay. The network cables that power the coupler, the regulator that's inside the coupler is working its tail feathers off. So if you go and put like 13 volts to this thing, that regulator is having to kill itself at the end of the network cable to keep the voltage up, to keep the coupler working. So we want to feed this a good source of voltage. 14 volt minimum, 14.5, 14.8, good to go. I asked him what the maximum voltage was, and he goes, you know, I've never just tested one to destruct. On the back of the meter, it says 11 through 16 volts, and that's what we're going to officially go with. I would strongly suggest to all you amateur operators that you might want to think about giving this thing a little bit more love. If you buy the wall wart from Telepost, what you're going to receive is a 15 volt wall wart. Keep that in mind. Just putting it out there for you all to enjoy. Right here we have a 1 amp fuse, and this is to help protect this whole shit and caboodle. But the thing that I wanted to show you that is inside is this right here. This micro SD. In the manual, if you read through the manual deeply and thoroughly, you'll find that this little micro SD, you can write to it. Now you have multiple different options. Oh yes, let's take a conductive screwdriver and start dragging it around on the inside. You have, I believe, up to 4 different user options. And what do I mean by user options? Well, inside this card is preloaded on this card some test audio. Why is that important, you ask? That leads us around to this jack right here. Inside this unit is a demodulation unit, okay? Which allows you to be able to have true sampling of what's passing through the coupler, whichever one you have selected, but also allows us to do test tones, okay? You're going to have 2 tones in a subcarrier system for Spectrum Mode. You're going to have a white noise tone that's preloaded on this card. You're going to have a pink noise, a 2-tone standard, white noise, and a 400 hertz sine wave that's loaded on board to this, a 1000 kilohertz sine wave, and then you have user options 1, 2, 3, and 4. So you can preload up to 4 of your own personal sounds to be injected through the coupler into the system. And you do it all by writing to this card. Now, are 99% of you going to use this function that are in the CB world? No. Is the amateur community going to take full advantage of this? Yes. How to properly take advantage of this? Once again, I'm going to take and point you back over to Larry at Telepost. He'll properly explain it, and it's also thoroughly covered in the manual. But I wanted to show you how to have access to the inside of the meter. It's nothing more than removing the screws admiring the beautiful craftsmanship on the inside of the tin, pulling the card out and writing to it. All the different formats are covered in the manual. Thoroughly covered in the manual. Let me put the lid on this and we're going to move on. Okay, so the reason we're starting out with this angle is I want you to visually see what I have set up here. Over here, I have our coupler. So we have power coming in from our Striker 490, our power coming out and going over to our input coupler for our 3 birds. So this is the 3000 watt element, peak envelope element, and setting up capture in this screen here is a little 4K handheld camera. Now, let's show you its angle. Now let's look down here at the camera. See this? See, look at how dark this screen is. Watch what happens. I just woke it up. So it was in screensaver mode. So let me switch back to cameras. Okay. So now that we see that working, let's go on over here and we'll zoom on in on our bird beater movements. So working from left to right, in the reflect hole we have a 5 watt slug, and that's going to demonstrate SWR or reflect. SWR is a term that is derived directly from reflect power. Okay, standing wave ratio to output power, reflect power. Then we have our average, root mean squared, bird watt meter in the middle. Nothing on, no peak kit, no nothing. I have a 100 watt element facing forward on it. And then I have a 100 watt element in 2x position. 2x. So, in the 2x position, because they don't make a 200 watt element, you guys, but they do make a 250. Right here, that little hash mark right there is 100 watts. Full deflection is 200. So, let's key the mic real quick. We're going to wake everything up. Let's switch back over to the Handycam. So, now we know our SWR isn't fluctuating, okay? We know it's not. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. Just me moving the microphone around in my hand is making this thing jump all over the place. So I know in the previous segment I pointed out that the coupler is taking a sample every 40,000 times a second, okay? So when we're in tune mode, which is right here, it takes that sampling rate because it moves so fast that the numbers would just be sitting here as a blur. Now what they've said is, okay, that's not really realistic to look at. For most people, that's going to give them a headache. For a lot of my guys, this is where you're going to have your meters sit a lot. Because my guys like to watch their meters. They're infatuated with it, man. Tune is 20,000 times a second sample rate, but it gives us a very, very quick reading. Hello, 1, 2, 1, 2. That quickly I seen, because I've been playing with it and I know what the radio puts out, is 172 watts peak power. It is what it is. We press this button. Now remember when we were talking about peak hold? Hello, 1, 2. I have it set for 5 seconds. That screen will not get rid of the data that it is seeing for 5 seconds. So for 5 seconds, your carrier can go back to 0. It could be undermodulated. It's only going to hold the peak that it sees for that length of time. So once again, set up, and we're going to scroll. Now me, being moi, I like to adjust things so that they move very quickly. We're going to adjust this down. Now peak hold at about half a second to me is a lot better than tune. It stabilizes things out. You'll see what I'm saying. Hello, 1, 2, 1, 2. Hello. Hello. 1, 2, 1, 2, 1, 2. Hello, 1, 2. Now remember, this is just a very good relative metering device. All watt meters, in my opinion, are relative metering devices. They're just relative power monitoring devices. To show you got all the right schmoo going in the right direction, doing roughly what it should. There isn't really an absolute, but this is pretty darn close. Now, let's switch views again. Okay, so now we're over here and we're looking at our bird meters. Hello, 1, 2, 1, 2. Because the refresh rate of the meter is so much faster than the bird, even with this peak kit on, the bird is slagging way behind the data that we're getting from here. Keep that in mind. This thing is way quicker in its information display than a bird because you have a mechanical device that is moving and sweeping over to its actual point. Now, you can make the bird meter read a little bit quicker depending on which peak kit you get in there, but we're not going to get into that. What we do have to do is validate the data that this meter is showing us to our birds. So I've seen about 172. Let's see, that one's showing me 100, 2, 4, 6, about 162, give or take 163, somewhere in there. So let's switch back over here. This is absolutely the worst way to demonstrate the accuracy of this meter was with a tone that is modulated with my voice. Hence the reason the test tone portion. You thought, oh my God, he's going to show it to us and he's going to be audioing in the microphone a bunch. Well, that's the way we're going to go about doing it. But that's an ability. That's something that Larry wanted to design out of this, and that's the reason he designed into it a demodulator unit that allows you, with line level output level audio, allows you to directly interject into your radio with pink noise or white noise, depending on how you want to set it up. An absolute, unequivocal, not going to wiggle around by oscillating our pitches or our tones, going to give you a true way to set up your meters. Food for thought. Now, the other way to do this what I'm demonstrating to you with the tone is that there's too much fluctuation with the human voice to be able to accurately judge on the lower end power levels clarity in the data that I'm showing you. It showed us 82 watts here, and it was showing us 83 watts over here on the bird meter to 81 watts. With a modulated tone at 1,000 hertz sine wave going into the microphone, we are seeing almost exactly the same data. So now let's go and let's tackle this one more other way. Okay, we're going to start out looking at the bird meters. Another way to tackle this is to just throw a base carrier. And that's pretty much how I'm going to proceed forward from this. None of this, audio, none of that. We're just going to throw a solid carrier. I know where my equipment's tuned. I know where I have it set up to run. We're going to use that. And believe me when I tell you I have several pieces of equipment here that I've built, designed myself. Once again, if you're new to the channel, you might want to click subscribe. I have lots of equipment over here that allows me to well exceed that 15,000 watt coupler by, let's see, 15, 30, 8 times. Okay, this is what I do. So there's another way that we can proceed forward without having to do a bunch of modulated tones and you guys listening to generated carriers and all that kind of stuff. It's with carrier level, just flat carrier level. So we're going to turn the mic gain off. You're not going to listen to me hoop and holler from this point forward. We're just going to show you maximum carrier level, or just what they call a dead carrier level. And we're going to go walk up through the scales and we're going to see what we can get. So there is 1 watt. The LP showing us 1.1. So either you can say, oh, it's off by 1/10, or we can accept the fact that there might be 1% loss either in the coax, the couplers, the connector, and or it is well within specification, because even Coaxial Dynamics and all the other meter companies in the world will tell you that it has to be with a 5% variance. You can't have a 1% variant part unless you custom accuratize the element itself on the spot due to the meter movement. So there's going to always be a little fudge variance there. That 0.1% means nothing to me, and I don't think it would to anybody else. And especially when we get up there in the higher power ranges, the variance between these meters, the elements, it really starts to show. Okay, I have a good feeling that this meter here, we're not going to see that variance with it. So let's go ahead and let's start here with the LP. Let's start running our carrier up. And it's showing me a 2.8, so we'll see 2.5. And now we are splitting hairs, you guys. Let's switch over to the birds. It is because of the angle that the camera is sitting at, it is showing us a 2.2. Back over to the LP, 2.5, fluctuating. So, with that being said, let's go ahead and run up into power level and see where we start coming back into things. Now let's switch back over to the birds real quick. Here we are back on the birds. Look, even bird will tell you, and Coaxial Dynamics will tell you the same thing. Because the scale is not linear, as in the digits aren't evenly spaced, we don't fall into the meter's actual true, what they would consider to be their test zone period, until we're in that top third of the meter movement, which is over here. They're expecting more variance down here low versus when we get up here towards the top. That's because the scale is not linear, and that is the way they have set the element up to work. So it is what it is. How close can we get it? I don't know. Let me look. It just dawned on me. I might have something that is going to allow us to see a little bit more clear. As I was shooting that last segment, it dawned in my little brain that I actually have a 1 watt element. I've got a 500 milliwatt element around here someplace, but I'm not going to go dig finding it, and we're not going to split hairs like that. It's silly. So without cutting away, and I pray I can do this without jerking the camera around too much, we're going to pan out and down, and I'm going to show you the 1 watt carrier directly back to the LP. So that way nobody can claim there's any kind of tomfoolery going on. So here we go. Here we go. Let that sink in for a second. Half a watt displayed, half a watt displayed. One watt displayed, 1 watt displayed. Good job. That impresses me a lot. Like, a lot. Okay, so let's start here. I thought that this would be a good opportunity to show you guys that maybe a watt or two isn't that big of a deal. And I want to show you with the exact same setup I have here. My meter, this meter here, is notoriously stingy. Notoriously stingy. I don't care what slug I put in there. I've had everybody you can think of. I tell them, when you come here, make sure to bring your 1,000 watt slug or whatever your most trusted slug is in the world, and I want to show you something. They show up and they bring their slug and they put it in this meter, and it's always a little low. I want to show you. It's just stingy. That peak meter is stingy. Look at the two. There's nothing that can be done about this. It is what it is. All meters have this variance that's built into them. It's because they were manufactured by man. So you're going to have a little bit of variance from A to B. But I wanted to demonstrate that A to B with you and show it to you in this format as well. What I have here is the 3,000 watt coupler and the 5,000 watt coupler, and I have them literally but connected together, and the network cables popped out of the side. This is channel 1, this is channel 2. This is what we've done all of our testing with till now, is on channel 1. So now, let's go ahead and let's switch over to the handheld. This is channel 1. In average mode. And this is channel 2 in average mode. We see the difference? Do this again. Channel 4, channel 1. See what I'm getting at? There's just a slight variance. Now let's go ahead and we're going to switch back over to the other camera. So right now we're showing channel 2. And let's go back over and let's look at our birds. What I'm trying to point out to you is we're still well within the 5% tolerance range. Well within the 5% tolerance range of what we're trying to display. I'm killing this little 2-pill that I'm using right now. Well within the 5% tolerance range from A to B, B to C. Okay? $102 is showing us a pretty stout 100. Let's go ahead and bump this up to where it's dead on the money. Still a little bit low from this angle. Sorry guys, from where I'm having to stand, I'm kind of standing obliquely to it. The average meter here in the middle, this one here, is solid 100 watts on the button. Then over here on the right, our peak meter is reading a little bit low on the carrier base. Switch cameras. Once again, check it out, 104. Hit the wrong button. 104. 103. There's always going to be a little bit of a variance. So you guys can get excited about 1 watt, maybe 2 either way. But from what I see, we're well within a 1% ratio. Honestly, we're within, well, we're within a 2% ratio. All the way around. All 4 meters agree. So now we have 4 different sets of data points. Okay, we have one that's a little bit low. That's going to knock the average down a little bit. And when I mean average is when we take all 4 data sets, add them together and divide them by 4, that gives you an average overall. Then from that, then we estimate what our predicted output power is going to be versus what our actual 4 data sets have given us. We're within a 2%. That's unbelievable. Taking into account your average consumed, accepted, most accurate form of measurement, being the birds, they come from the factory with a 5% variance in them. Any one of you guys that's ever had to mess around with having multiple elements in a metering situation, like what I've got going on my workbench, will go, oh yeah, it is what it is. So I've showed it at 1 watt, I've showed it at 5 watts, we've showed it at 100 watts, we've measured it across multiple platforms. Moving on. Let's go start playing with some real power. And let's get rid of all this little small hibbly-jibbly coax I got going on feeding everything. Because I'm ready. I'm really, really ready to go see what we can do. I think this is where the video is going to get fun for people. Oopsie. I'm just going to show this real quick and then we'll move on. My exhaust air temperature coming out of this little tupil is 143.9 degrees. The actual cabinet case itself, 128 degrees. 142. There's 3 little 1-inch computer fans that I have slowed way down in the vents, and they're pulling air into the cabinet and exhausting the hot air out this way. And that's what we're measuring. Like I said, I was murdering this little guy, but it's all for science. Okay. You guys, this next little segment, not this one, but the one coming up after it, is kind of got me a little sketched out. And it's not from the coax. The coax can carry it, although it's incredibly lossy. Now remember, when people talk about loss, there's 2 forms of loss. You have signal loss and then you have heat resistance loss. The 393 can carry this amount of watts that we're going to produce here in a few minutes, but I would strongly not suggest doing it. Okay? You're going to want to do something different. Like for this particular situation here, this is, what was this, 217? 218. I don't know, I don't run this little stuff anymore. 218. So we're going from inch and a quarter to an 1 5/8 line section to reduce it down to a reduction plate to go to 218. So it's flexible for me to bring it to the workbench. And then from that, then I wasn't thinking, I should ask him to make this 5,000 watt coupler with like 7/8 connectors on it. I didn't, my bad. PL259, but the PL259 SO239 connectors will carry 15,000 watts in peak mode. The coupler can handle 15,000 watts in peak, but I wouldn't suggest it as a carrier. Okay, but we're going to test it as carrier because I want to see what we got for signal variance. So once again, we've got the 4K Handycam pointed down here, and we're going to flip-flop back and forth between the two. Now, the next thing I want to point out to you guys is what I'm going to do here is, well, not really the safest or the smartest thing in the world, but we're going to do it for your YouTube pleasure. Also want to hyper emphasize that we have now added ground braid. So let's back up what I've shown you here. Let's zip over here and take a look at the coupler. That's the 15 kW coupler we're going to start off. That's a 1,000 watt element. And then we've got substantial ground braid. You guys drive me crazy. I don't understand. You'll spend thousands upon thousands upon thousands upon thousands upon thousands of dollars on your radio equipment, and then it comes down to ground and bonding, and you guys will go get like a piece of 22 gauge wire and be like, well, I grounded it. Well, no, you really didn't. Because there's a huge difference between an electrical ground and an RF ground. Okay, RF ground needs to be flat, smooth, big. Big. Preferably you want to make it bigger than whatever your final feed point coax is. Why do you think at the AM broadcast stations they got big old flat pieces of copper strap going in between all the different pieces of equipment? Because you can achieve both kinds of ground, electrical ground and RF ground. But the RF ground has to be more substantial than your coax. It's a TVI thing. It helps keep RF interference off the coax. So, like this situation here, that leads me into this next little segment. That I know that this is a network cable. It is deceiving. It is twisted pairs of wire that are bonded and shielded, but still, it's not a digital setup that's going on between the two. He's capitalizing on the quantity of wire so he can be able to power, have all his send signals and everything going between A and B. He said even at this particular power level that we're going to eventually work our way up to here in a minute, that it is most advisable that we use an extra bond to the coupler and make sure that we have our voltage set up properly above 12 volts at 14.5, feeding the supply. That way the regulator that's inside the coupler has enough current to accurately do the job. I'm sharing all of this with you guys as knowledge. If you start to see the coupler start having weird funky readings on it, put some ground strap on it. And I'm not talking like wire that you pulled out of your grandkid's toy. Use something wide, flat, substantial. Solder the eyelets. Do due diligence with grounding. Grounding is just as important as your amplifier, your radio, and your antenna. Believe me on this. My station is grounded with about 5 or 6 straps of that off the tower, and 5 or 6 straps of it at my grounding plate at my station, going to independent ground rods on the opposite side of the wall, shortest distance possible. Each one of my pieces of equipment is bonded together with 1-inch. Coming off the final stage section, I've got this big tugboat wire that I use. And what do I mean by tugboat wire? Is it literally came out of a tugboat yard. Ground braid. Use ground braid, you guys. It's got the name for a reason. Flexible wire braid. It's important. This is important. I can't even... But all you guys out there running your little 6-gauge, bought at Home Depot, Romex wire, hey, right on, good for you. Okay, so the fittings are what's stressing me out. It's not the wire. And it's the massive reduction to get it down to this level. So first off, let's go ahead and start like this. I got to walk over to another part of the room here. Okay, so we got the 4K camera pointed right at the LP500. Now, what we've got here is a 1,000 watt element and a 10,000 watt element. First off, we're going to go and we're going to take this to 1,000 watts. I got a 3,000 watt coupler in the hole. Let's back this on down a little bit so we don't blow everything up as soon as we fire down with this monster. Let's run this on up. Switch over to the LP, back to the bird. As you can see, we're climbing. As the tube's heating up in operation, it's starting to climb. Back to the bird. It's close enough for the girls I go with. And it's still climbing. And the warmer the tube gets, the thing that's just going to keep climbing. Having a hard time keeping the restraints on it, let's say. Okay, so let's click back over here to the birds again. Let's put that 5,000 watt element in there. Now, I know for a fact the 3,000 watt element will read a little bit past 5,000, or a little bit past 3,000 watts. So, let's start out here. There's 2. Come on, quit hopping around. It's as close as 3 as we're going to get. LP. Bird. Okay. We've got it. We've got it. Let me go ahead and let's switch couplers. Should take just a minute. Okay. So here's the trick, you guys, is that these couplers are designed to read peaks up to 5,000 watts, not 5,000 continuous, okay? So we're gonna run up against a brick wall once we get close to 5,000 watts. It just is what it is. The 3,000 watt coupler will read to like about 3,500 watts and then it just stops counting. We're gonna have the same issue present itself with the 5,000. We don't know where that's at, but it's going to be really close to the top end, within 100 watts or so of 5,000, I'm pretty sure. So the best way to find out where that's at, I think, is going to be with experimentation. So let's go ahead and let's put some juice in the wire. Here's 2,000. There's 3,000, 4,000, 46, 47, 48.25. So the brick wall for this line section stops at 4,825 watts. So let's go ahead, let's switch over to the handy cam. And we'll see that. I'm putting about 5,000 in it and we've hit the maximum that this thing can read. We don't want to exceed that very much more because we'll end up burning up the coupling diodes inside the coupler. But we're right up on the brick wall. So it doesn't matter how much more energy we put into it, it will singularly count all the way up to 4,875 watts. Like we said from the beginning, this is a peak coupler, not a continuous carrier coupler. There's a big difference. Okay, so that means the core inside this unit is reaching saturation, which is perfectly fine. That's what it's designed to do. So we know it'll read accurately a solid carrier up to 4,800 and some change, which was displayed on the meter, on the LP, and also displayed on the bird. It showed up that we were just continually putting more carrier in it, and the needle's not going over any further on the counter. So that's good. It shows me that we've got a balanced measuring point, 3,000, 5,000. Let's do an accuracy measurement. Instead of focusing on where the top end is at, showing roughly 2,000 bird, at least from this angle. 2,000 bird on the 2,000 watt slug. Let's switch over to the handy cam. It's within 80 watts. I'll take that and I'll run away with it. All right, back over to the birds. So it's reading dead on the money. We just hit that brick wall at the very top end of the coupler. Oh well, no big deal. Now, when we want to go above about 5,000 watts carrier, this is when I start questioning all my other couplers in the line section, you guys. These units here, these joints. So now that we've been fiddly farting around with it, let's see what we're at for temperature wise here. What do you mean by temperature wise, BBI? Oh, that's hot, especially on the bend. That's not too bad. So over here behind the meter, I got 393. It's only about 100 degrees. Only about 100 degrees. That was some foam-based coax, that shit would have melted. Okay, let's go give it all the jam that she's going to take. Let's flip over and let's get this done. Now what we got going on, once again, is we got the 4K Handycam sitting down there, giving you a close-up, and we're going to zip over here, and we're going to take a look at the 43. Now I went ahead and I removed all the other line sections because I want to remove the opportunity to have something catastrophically explode. Like, I don't need to have 4 couplers in line when all I need to have is 1, right? So this is the 5,000 watt, as you can very clearly see, the 15 kW line coupler. Okay, so let's click down to the little camcorder. And that's too much. There, we'll put 0.3 of a watt. Now, according to everything on this side of the room, I'm actually putting out about 2 watts. So you got to think how many different connectors I've got all of this going through to get it to where we're at now. The driver, about 60 watts of carrier. It's going to be really hard to get the tube to settle down here, you guys. So it's showing us 1,000 and 1,000. Now, I told myself as we were doing this, I was going to verify. Trust but verify, as they say in the Russians said it first, the Americans, Ronald Reagan picked it up next. Okay, I'm showing 1,000 here. Over 1,000 there, and about 1,000 on the LP. Okay, so let's go ahead. We're going to take the 1,000 watt slug out over here in the 3 1/8. We'll pull this 1,000 out, and now we're going to put in its place a 5,000 watt element. Okay. Sure, I can clearly see the 5,000 watt. We can. Everybody's happy. Happy, happy. Let's go over here. There's roughly 5 grand, 5 grand here, 5 grand over there. We're showing about 4,000. There's 5,000 watts on the LP, right at about 5,000 displayed and 5,000 over here. Okay, now let's switch back over to the camera, the big one. Let's turn on our FLIR. We're not overly hot yet. Okay, well, let's go back over here to the 43. I'm really comfortable right now where we're at. This is where things start to get really sketchy to me. So we're going to go to a 10,000 watt slug. 10,000 watt element installed. Let me come back over here to this meter. That's 50K, I don't need that one. It's 25K, I don't need that one. 10,000 watt, here we go. Here we go. So let's get it in this coupler too, that way we don't have a bunch of RF leakage going on in the room. So we left off roughly about 5,000 watts. And we're once again at about 5,000 watts. Let's go ahead, we'll roll this on up. There's about 10,000. And we're showing roughly 10,000 again displayed. Once again, I'm on the way bottom end of this thing. So I'm on the bottom end of this amplifier. What I mean, we're not even close to the top. Right now I'm putting 2.4 watts. And the driver is producing about 480 watts of drive. And it's producing 10,000 over. We're real close to it. Yep. So let's see where we're at with heat. Switch back over to the big camera. I mean, that is some couple seconds of keying. The ambient heat is 75, 74. (98 to 100 degrees). Just with them couple seconds of keying, and it's warm. Okay, let me let everything cool down. I'm just going to cut away here on this last little segment as we're getting ready to run up. Let me explain what happened here. So this is an experimental, non-commercially available coupler. This is a modified 10,000 watt coupler. And it was produced in a series of test pieces. And we were pretty confident that this was going to work. It hit the brick wall at about 13,000, and it wouldn't count any higher. So, needless to say, this is going to go back with the test results attached that are for him, and he's going to continue developing this for commercial use. Now, the reason he sent this to me is because I do build commercial equipment. And I mean, a lot of what you guys get to see on the YouTube channel here is amateur and CB equipment based. But there is a commercial side of this business to where I do some things from time to time. So he sent me this as a test piece. So we got his results. Unfortunately, we weren't able to take it up to the full 15 kW. It made it pretty close. But at the end of the day, it is what it is. It's going to go back, and it's just a product in development. So maybe we can learn from this. We can all learn from this, and then we can have bigger couplers available to us. But on the other side of things, this, and this, and even this, all accurately did their exact jobs that they're supposed to do. Like I said, this is a modified 10,000 watt coupler, and it accurately read all the way to 10,000 watts. So, on that note, let's wrap this dog and pony show up. There's one little more clip of video that I want to show you here. It's one more specific function of measurement. I did not do the modulation meter test for a reason. I didn't want to open that can of worms. I'll leave that up to somebody else. The modulation meter does work. You need to be in a quiet environment when you do it, and it does actually do the form of measurement, but I'm not going there. What I want to explain to you guys next is another form of tuning your amplifier. And if you follow the instructions and you get the hint of what I'm talking about next, it's actually a pretty trick-ass way to tune your tube amplifier. So away we go. Okay. So we just left off. The last segment was us testing the LPC 505. They've only produced one of those couplers, and it's for a commercial application. And I ordered one. It's not listed on the web page in any way. And let me make this really clear that I am just me, and I am just looking at this meter, and I'm playing with it, and I'm enjoying all the different functions that it does. I am in no way associated with or have any endorsement from Telepost Inc. They're just a meter manufacturing company that's at the very top end of the game, in my opinion. I purchased this meter. It was not sent to me to review. I am me and me alone. So the amateur community loves the heck out of this meter. It is geared for the amateur community and the commercial side of things. and I am coming along third party and just making my observations with the meter, and it solely falls on my shoulders. Okay, now that being said, the LPC 505 line coupler, after we got over about 13,000 watts, the core inside the coupler started to hypersaturate, and it, it will work in a peak mode operation, which what I have here for equipment for that, I would very quickly oversaturate it. So I'm going to just cut the testing off at 10,000, and I can guarantee that the coupler will work to 10,000. The 15 kW coupler, which is not available to the public in any way, we're going to revisit that in a later video. There's a couple different things there that we're going to attempt. We're going to make a couple different models, and we've got to see what works. It's a thing that's in development, is the best way to put it. He's got a commercial company that he works with over there that they're going to help him develop that, and I'm going to leave it just there. But please listen to me when I tell you I am in no way associated with Telepost. If you have any questions or anything that you need to have answered about this meter, please contact Telepost. That's it. He's not trying to develop huge couplers for the CB community or anything else. He's trying to work on something for a commercial application. So we are in no way wanting to gear this video towards a specific community in the radio world. I'm doing this as an overall review. Now, the last and hardest thing to try and explain to people, this is a function that's built into this meter that I want to make sure I cover. It's called Trapezoidal Tuning. He covers it in the manual very thoroughly. And it has taken me 2 days of racking my brain how to take what is explained in the manual here, back here. And the best picture of the trapezoidal tuning, I can't remember which page it's on, is he shows the graph in the spectrum display and its amplification over time with input power versus amplification output power, and it's a graphical result of that. And how you're going to be tuning this is going to be with a pulse operation. Now, the coupler does not inject the tone. This is something that you can utilize the demodulation unit on the back to inject the tone into your radio, and we're going to explain this to you. The best display of that is here. You have your waveform and envelope growth. So we're going to have a pyramid shape of amplification. So you're injecting a growth pulse signal. You can do it with your voice, but it's best to be done with a tone generator. And you're going to have your display on the meter. And you're going to have a center bar that comes down the middle on the meter. It's going to look remarkably like that. Now, what we have to understand about trapezoidal tuning is that you're going to put a coupler at your transmitter or transceiver, transmitter unit. So it's going to measure the input voltage going into the amplifier. Then you're going to have a coupler that sits between your antenna and the output of your amplifier, and it's going to measure the signal growth over the input voltage. So it's looking for the small amount of signal that's coming from the input, and it's making some quick mathematical adjustments, and it's looking at the output voltage of the amplifier. Now, what's really cool is you're going to start out with a graph that goes like this. The length of the display, let's go ahead and fill this in. The length of the display, the bottom width of the display, is your driver, volts, or driver, input. And we're looking at how much signal that we're putting into the amplifier. Now our envelope, as it grows, going this direction, this measurement is amplifier signal growth. You can adjust your amplifier with your input drive and your output tune, and you know that you've reached your max zenith when this starts to curve over and starting to flatten. You want a nice, hard, sharp point is what we're looking for at the top. That tells us that we no longer need to input drive. No more drive from the radio, because the amplifier has reached its maximum amount of input. So now you're going into a state of operation where you're overdriving the unit. This is trapezoidal metering. It was a little hard for me to get my head wrapped around how I was going to explain this to you guys, because I don't like to use big fancy words. It's a scale system of being able to describe input drive over output signal growth, or how much amplitude your amplifier is actually making, where you're reaching your maximum saturation for output versus input signal. Now that I understand how to think about it, it makes it easier for me to be able to explain it with a visual aid and just drawing it out on a diagram and explaining to you what that means. So your signal growth up vertical and down on the meter is showing you the output reference, or otherwise the voltage that this coupler is reading on the output of the meter, or the output of the amplifier. And this is showing us our input voltage this direction. And we're wanting to tune this until we have a completely sharp point. And this is strictly in pulse mode. Whoop, whoop. You can do it with your voice as well. But there's a generator that's inside of this thing, like I've referenced several times in this video, to where you can take the output signal from the meter and feed it directly into the microphone jack in the front of the radio, or line level input. You might need to put an EQ unit, like a simple 3-channel mixer, between the audio jack on the unit to match up the proper input impedance and a proper signal input levels for the microphone jack on the front of your piece of equipment. But this is just one more function, has nothing to do with the absolute watt operation SWR function. Another way for us to be able to measure input drive over output power. Helps us establish more of a linear curve and know that when we're reaching our maximum saturation point, so we don't overdrive our equipment. Trapezoidal measurement. Brilliant. Brilliant. Well, guys, in conclusion, I just want to wrap this up and bring this whole story saga to a close. I told you all at the beginning of the year, those of you that are subscribed, and like I said, if this is your first time watching and you've enjoyed watching me blunder my way through this video, take a minute, click subscribe. I'm always trying to generate content like this, and I'd appreciate your support. I told you that this was going to be the year of the watt meter. I've done 5 or 6 different review videos on watt meters to this point. This is just one of them. And like I said, if you have any problems, questions, or anything, you need to contact Telepost and go from there. I am not the Telepost whisperer, and I'm not going to help you get your settings set up or any of that. That's not my place. This is by far the most impressive watt meter I've come across that is a digital-based measuring platform, by far. It's been in development for a long, long time. In this same class of watt meters, this one stands above the others, in my opinion. I've had the opportunity to play with the other 2 that are somewhat in this class, and it is what it is. This is the one that I find the most interesting to me. And I hope that you guys have gotten some enjoyment out of this. Guys, the LP500. Very impressed. The only difference between the 500 and the 700, by the way, is the display. And I'm going to say this, the next watt meter up for display is another Bird device. The 4342, the dual needle. Coming soon. But on this note, gentlemen, my name is BBI. And I'm truly grateful that I get to be here. I get to do these things. I get to work on these projects for you all. And it's a lot of weight to carry on my shoulders, but I'm doing good, the best that I can, and I appreciate everybody's support. So on that note, I'm going to take off and go. On to the next one. Big shout out to Excess Power, big shout out to Siglent, and a big thanks to Bird and Coaxial Dynamics. And last, but first, thanks to every single one of you. Because without you, I don't get to be here and I don't get to do this. And right now, I'm living the dream life. And I say thanks to all of you guys. I'll see you. Bye-bye.